I do appreciate it, sir.
All right. So we got three routers. First, we are going to have static route, followed by routing protocols one by one. For that, I'm going to take some loopbacks on each router. Loopback 0. The IP address for testing that we are taking is 1111:1111/128. Because it is loopback, you can mask it with 128 bit. And on router 2, it's going to be 1111/2222 here. Because it is fully masked, I can do this. I can have that same 1111 as for the first 16 bit. And here on the last four number is going to be 3333. And next is assigning IP address. We have already done this. So we learned how to assign IP address, but unfortunately we have not saved the configuration. We're going to quickly do that once again, and then we'll get into the routing part. I'm starting from router 1. So Sam, you are lucky. I'm going to redo the lab which I did in the previous class. Interface loopback 0, IPv6 address. We're going to put 1111:1111/128. And then on the loopback, so on the Ethernet, IPv6 address 2000:12:1/64, which means out of 128, the first 64 is network, and the last 64 is just one, many zeros and one, the interface prefix, the network prefix and the interface prefix. All the remaining bits in the middle are zeros. If you watch the day 1 of IPv6 class, you will understand this much better. After watching, bring your questions. And I say no shutdown to bring it up. You will see a link local address generated for these two interfaces which we configured. The addresses. Show IPv6 interface brief. You can see here. A link local address is generated. And a link local address will always start with FE80. This is for neighbor discovery. And this portion is made out of the MAC address. MAC address is 48-bit size. To make it a 64-bit, the FFFE is injected in the middle to make it a 64-bit. Now let us go to router 2 and do the configuration. Interface loopback 0 IPv6 address is 1111:2222/128. And on the physical interface, we got 2000:12:/64. Here we are not interested in giving the interface prefix. We ask the router to use the MAC address, which is called as unique identifier, and extend it to 64-bit. I bring it up. Likewise, I go to interface Ethernet 01, and I would like to give this as an IP address, DAD:2, IPv6 address, DAD. This is not a case sensitive one, so you can have lowercase or uppercase, it doesn't matter, ::2/64. Here the complete 128-bit is assigned. 64-bit plus interface prefix 64. So totally 128-bit is given. Whereas in the previous case, only 64-bit of information we gave, other 64 was derived from MAC address. That's what I mean. The network portion is only 64 on both the cases. Now, show IPv6 interface brief. We have here one side EY64 assigned address. This portion is made out of MAC address. So the link local address, interface prefix, and the global address, interface prefix, both are matching because both used the MAC address to get this. Now, what about the loopback interface? Loopback interface don't have MAC address, but they need MAC address. They copy the physical interface MAC address, so the link local address will also be same. You see, the link local address of the physical interface and the loopback interface are same. That is okay because the scope of link local address is only on the link. What I'm trying to say is on a router, on a single router, you can have the same link local address if you want on all interface. You can have the same link local address on every port of the same router. But what you should not have is you see, the link local address here and here must be different. But the link local address here and here can be same. No problem. Because the link local address scope is only within this limit, within this link. So if two link have got same link local address, it won't conflict. Because this is not going to negotiate here, and this is not going to negotiate here. The scope is local to the link. So for example, if I have here FE80::1, here also I can have same. Can we assign link local address statically? Yes. Here it is dynamically allocated, right? I can make it statically. Now you see, I'm going to change the link local address. Same on both physical interface, and you're going to see that. Interface Ethernet 0/0, IPv6 address, FE80. See, you have to start with FE80. Though you are doing manually, you have to start with FE80, ::2. And then I have to define it as link local. Likewise, I'll go to interface Ethernet 0/1. Same link local address. Even on the loopback interface, same link, nothing wrong. On a router, you may have same link local address on all the ports. Show IPv6 interface brief. You see, same link local address allowed. Now, because I changed the link local address, that EY64, you see, it is not using the MAC address this time. Whatever is configured in the link local address as the interface prefix is copied. These things, we should know. Earlier, before changing link local address manually, it was different story, you see. But after I change the link local address, whatever I gave in the interface portion, it is copied here. Okay, so router 2, router 1 is over. We have configured the IP address. On router 3, we don't want to give IP address. We want it to be auto-configured. For that, router 1 should act as a server and 3 should act as a client. For that, router 2 first need to be a IPv6 router. By default, IPv6 routing is not enabled on the interfaces. Only when R2 is a IPv6 router, it can provide that auto-config service to the client. So I say IPv6 unicast routing command to enable IPv6 routing here. So this makes router 2 ready to support auto address configuration on router 3. Let's go to router 3 and get the IP address configured automatically, dynamically. Let me first put the loopback interface IPv6 address 1111:3333/128, and then interface Ethernet 0/0. I'm going to say auto configure, you see, and we will see address configured dynamically. Show IPv6 interface brief. You can see address is dynamically configured. You can go now and ping from router 2 if you want. You can ping here. Router 3. See the readiness, not even a single packet is lost in IPv6. Because, the link local address discovers the MAC address of the neighbor router before you ping. As soon as the link comes up, it will go and discover the MAC address of the neighbor router, which we saw by debugging in the previous class. So this is the condition of the previous class. We had these IP addresses ready. Now routing is what we are going to try. On router 1, if you check the routing table, show IPv6 route, we don't have routes to reach the network behind router 2, like 1111:2222, DAD colon, and then 1111:3333. We don't have routes. As a result, if I ping, I'll not be able to ping 1111:2222. I'll not be able to. Hold on. Am I pinging this? 1111:2222. Not possible. So how is this 1111:2222 is pinging? Let's check. Show IPv6 route. It says neighbor discovery ND default, and it is sending to the gateway. You remember this address ::2 I gave manually on router 2 link local address. It says it is forwarding the packet if it don't know anything with a scope of 1, and this is in 1 hop away, so it is able to discover. But when you try pinging 1111::3, the ping doesn't happen because the scope is not within 1 hop. See, this is not pingable. Let me do one thing. I'll change the loopback address. Instead of 1111, I'll change 2222 and check whether I'll be able to ping that 2222 from router 1. Interface loopback. Okay. Okay, I'm going to teach you something new also here. I'm saying 2222:2222/128. See, in IPv4, When you put an address, it will override the old address. It will override the old address. Whereas in IPv6, it won't override. Now you got two addresses. I would like to delete this. I don't want this. No IPv6 address. 6 address. Okay. Now we don't have the other address. We just got only one. Let's try pinging this 2222. I'm able to ping, which I just configured, which means the advertisement of the router one hop away is coming down here. I'm able to ping, but I cannot ping not possible. Let's see one thing. Let's do enabling routing on router 3, IPv6 unicast routing. Even then I cannot ping. So because it's more than one hop, you need a static route or a routing protocol. You cannot ping this 1111::3. Can I ping from router 2? Show IPv6 route. I don't have the default route. Why? Because this is a router. Router 1 is not a router. Router 1 is still a host. That's why I had a default route for the neighbor discovery. A default route as the next hop router for neighbor discovery because this is a host. But when I do IPv6 unicast routing, I'll not be able to ping the 2222 address. See? So to show you practically, I did this small drama. You were able to ping when I was having R1 as a host because hosts usually have a default gateway. When routing is not enabled on R1, your routing table was not like this. Not like this. You had a ND neighbor discovery and you had a default route. This is how we write a default route: ::/0. And it was pointing towards the next hops link local. And this is the exit interface. But when you make it as a router, you will not find that default exit anymore. Because it's a router, it may have multiple exit. You need to specify the exit manually. So I'm going to write a static default route on R1 so that I can ping again this 2222. How to write a static default route? IPv6 route. : means what? Any network / any subnet mask. Send it to 2000:12. I need to know the MAC. I need to know the IP address of R2. So let me go to R2 and copy it. Show IPv6 interface brief. This is the address. This is the next hop, the gateway. Right? I hit enter. So I have written a default route. As a result, show IPv6 route. You see, I have written as default route, but this is not ND, this is S. Statically, I have written. I'm not using link local address. I'm using, if I use link local address, what will happen? I have to also mention the exit interface. You see, I was telling you the very first day that the link local address are not pingable. If you want to ping using this link local address, you need to mention the interface. Let me show you once again. If I try pinging with this, it's asking me the outbound interface. Now it pings. Without outbound interface, you cannot ping. That's the reason why I did not give the link local address of the next router. I'm giving the global unicast address. When I give global unicast address, what is the advantage? I'll be able to learn the neighbor because I know where is 2012. 2012 is via Ethernet 00. So I can discover this gateway via this interface. Will I be able to ping now 2222 colon 2? Sorry, colon 2222. Yes, I can ping. So we got reachability up to router 2. Can I ping router 3? Of course you can ping, but the return traffic will be the problem. If I ping, definitely router 2 will receive the packet. But router 2 won't forward it to router 3. Even if router 2 forwards, router 3 don't know how to come back. So we need more static routes. On R2, I'm going to write static route, show IPv6 route. In R2, there is no route to reach 1111 colon 1111. Also, we don't have route to reach 1111 colon 3333. So we need to write two static routes. No default route is possible in R2. Or one side you write static route, one side you can write default route. Just only a default route will not work on R2 because it's not a stub router. So what do you want me to do? You want me to write a static route towards R1 and default route towards R3, or you want to write two static routes, one via R1 towards R1 and another one towards R3. What should I do? Okay, both sides static routes. Okay, I'm going to say
Static
IPv6
route
route
means
1111 colon 1111. If this matches 128, then you need to send it to 2000 colon 12 colon 1. And IPv6 route, if you find DAD, sorry, 1111 colon 3333 slash 128, then it needs to be sent to router 3. What is router 3's address? Router 3's dynamically built address is this. Done. Show IPv6 route. You can see those two static routes here to two different gateways. Now, if I'll ping from router 1, the packet will go to router 3, but I will not be able to get the response. The packet goes actually. What is the proof? I'll show you the proof. Go to router 3, debug. Debug IPv6 ICMP. Let's ping again. See, I'm receiving the packet from, this is router 1's address. For the destination, this one. And when I'm trying to send an echo reply, the routing table says show IP route show IPv6 route. There is no route to reach 2012. As a result, the packet drops. So let's write a default route. IPv6 route. Send it to DAD::2. After doing this, because you got the default route, the ping will be successful. See, not even single packet lost. That's why IPv6 is called as, ready, always available, always ready. The readiness, not after you ping, it is going and starting the ARP process and learning the packet, then pinging using ICMP. It's not like that. Before your ICMP ping goes, it already knows the MAC address of your adjacent routers. Static route is over. You want me to try anything in the static route? Any changes you want me to make? Please let me know. I'll do the changes. If not, we need to move to the next level.
Sir, if we have a dual stack like IPv4 and IPv6, so it's like IPv4 address is no need to match with the IPv6 address, right?
See,
I mean, I'm
what is
just asking
dual stack?
how it will be.
You have both IPv4 and IPv6 on an interface. Not only that, sometimes you may also have OSPF for IPv4 and OSPF for IPv6. So it's going to be two separate control plane. It is going to be two separate control plane, two separate routing table, two separate protocol to discover and distribute routes. So there is no need to have any match between these two protocols, not necessary. I don't know what make you to think like that. You ask me in more detail so that I can explain you more detail if this answer is not satisfactory. Sorry, I didn't hear you. Did I answer you? The control planes are
Yeah,
separate.
it's, I mean, yeah,
IPv4
could you repeat once
control
again, sir,
plane
if you
is
don't mind?
separate. IPv6 control plane. You have separate routing table, right? When you
Okay,
type show
IPv4 is separate
IPv6 route,
IP.
you see the IPv6 route. So there is a separate buffer allocation. Both are not sharing the
Okay.
same
Okay.
buffer, or even the RIB process is separate. Routing information base is separate. And if we are using a routing protocol, even the routing protocol process is separate. So there is no need for any tie between these two. There is nothing need to be come as a tie in between. There is nothing need to unite these two together. Uh, they are independent. There is no need something to match in common when you have a dual stack. Please ask me a question. If I didn't get your question well, then I will not be able to give you the answer. If I didn't give you the answer, ask the question again. I'm waiting for your question.
Yeah, I'm good,
Okay,
sir.
can you repeat the
I will
question?
also do some lab on IPv6 with the dual stack. Then I will come back to you. Yeah, my question is like, for example, IPv4 10.1.1.1/24, for example, interface Ethernet E 0 by 0. So
No,
does this
okay.
IPv4
No,
address
no,
is
there's no need.
100%
There's no
required to match
requirement
with the
like that.
IPv6 address?
Okay, if you're
No way. Okay, fine.
trying to
No.
do a tunneling technique called 6 to 4 tunnel, then that IPv4 need to be embedded into IPv6. That's a different tunneling technique, which we'll see later. But for simple IPv6 network without tunnel, there is no recommend like that. You no need to have IPv6 and IPv4 embedded into each other address. Okay, so there is no need for IPv4 address to be embedded into IPv6. That's the answer. Let us move on next. I'm going to remove the static route and we are going to enable a routing protocol. So what routing protocol do you want me to do first? Which routing protocol should I do first?
Yeah. Shall we go for B? I mean,
It's going to,
IGP like
if
OSPF.
necessary,
I mean,
we'll
can
do
we take
it,
more routers?
but it is going to only consume the time. You tell me what
Can we
exactly you
take
want. I'll
more
try to
routers
put it
and
in the
two
same
different?
topology. More router, I want you to try at home. After that, if you still need me to have
Okay.
more router, then I'll have more router. According to me, with this 3 router, I can even show multi-area in OSPF.
Okay. Yeah. Then let's keep these three routers like one AS, and let's keep two more routers in other
Why
AS,
you are going to
and
BGP
we'll
after
do the
seeing OSPF?
eBGP.
Hmm. I said only one protocol. Why
I
you
mean,
bring
IGP
BGP now?
will configure OSPF, but in the
Let's do
border routers will
OSPF first.
configure BGP.
Okay.
Okay.
So as I
Then
was
let's go
talking to
for,
you, I also
yeah, sure.
removed the static and default routes that I configured on all the 3 routers. We are going to enable a routing protocol to distribute the route information so that we can ping again from R1 to R3. Earlier we were pinging this, but now if you try pinging, there is no route, the ping won't happen. You need routing protocol support because you don't want to have a static route. That's why you remove the static route. And you suggested me to use OSPF. Sam, do you remember OSPF? Okay. Okay. Now today we are going to see
Yes, sir.
OSPF
I was actually
IPv6
listening to your
OSPF
class the other
configuration.
day, the ones that we had
Now,
before.
first thing is I need to enable this command IPv6 unicast routing before you enable any routing protocol. You have to do this one, otherwise it will throw error. Without giving this command, see what happens if I enable IPv6 routing. I removed this. Now I'm saying uh, IPv6 OSPF process ID 1. You see? Sorry, IPv6 OSPF. Come on, go to the interface. Uh, IPv6 router OSPF process ID 1. You see, it says routing is not enabled. Okay, what about EIGRP? IPv6 router EIGRP 10. Again, same problem. Let's try RIP. IPv6 router RIP SAM. See, again, it says the same. There is no command called IPv6 BGP. For BGP, as usual, you will type router BGP. Fine. So what I'm trying to say is if you want to enable any routing protocol, make sure you put this command IPv6 unicast routing first. By default, this is not enabled. Now let us move on to the OSPF configuration. even though we are doing IPv6,
Enable.
the IPv6 routing protocols need a 32-bit ID as a router ID. 32-bit address, like IPv4 address, as the router ID. If I will have any IPv4 address on this router, it will be automatically picked up as a router ID by IPv6 protocol. I repeat, when I enable IPv6 OSPF routing protocol, it needs a ID, and the ID need to be 32-bit in IPv4 format. So that router ID you can manually give, or if there will be any interface with IPv4 address, the router is going to pick from the interface. So let us now check this. I'll go to an interface loopback 0 and put an IP address. This is an IPv4 address I'm doing. I'm putting this address not for any communication. I just want IPv6 OSPF to pick this address as its ID. Okay, if you check now, show IPv6 interface brief, you have an IPv6 address, and when I type show IP interface brief, I have a IPv4 address. This is what we call as dual stack, having both in one process or interface. Now, the purpose of me putting here is not for routing, it is for router ID, IPv6 OSPF router ID. Not only OSPF, even BGP, EIGRP, RIP, they all need router. Even RIP needs router ID. EIGRP, even EIGRP needs router ID. Not RIP. EIGRP needs router ID in IPv6. So when you are not ready to manually assign router ID, at least make sure that there is an IPv4 address on the router that can be used as a router ID. And that address need not to be a pingable address. You cannot ping this address from anywhere else. You don't have IPv4 on the Ethernet links. Now, I'm going to enable OSPF. See how to enable OSPF. Go only to the interface. Because I don't want router ID to be manually configured. So I'll go straight to the interface. IPv6 OSPF process ID area 100. So what is the area in which loopback is? It's area 100. This side is area 100. We all know OSPF very well. It needs a backbone area. So I'm going to make this as a backbone area. Area 0. And this loopback of router 2 will be area 200. And loopback of router 3 will be area 300. In the middle, to connect this area 100, 200, 300, you need area 0. So I'm going to keep these two interfaces area 0. Tell me why I need big topology. Not necessary. Let us do this. So here, all three routers are ABR. All three routers are internal. Now you cannot call it as internal. They are all also backbone. R1 is ready. If I put one more command, that is area 0. Correct? Ethernet 0 on R1 is area 0. Let us verify. Show IPv6 OSPF interface brief. You can see two interface. Interface Ethernet 0 is in area 0. Loopback is in 100. Let's check the router ID now. Show IPv6 protocol. Look at this. IPv6 using IPv4 address as the ID. And this is an ABR because it's a member of both area 0 and area 100. You can also know this by typing the command show IPv6 protocol, show IPv6 OSPF. You can see here the router ID. OSPF version 3 means what? IPv6. And you can also see it's an ABR. This got membership on both area 100 and area 0. Why area 0 is inactive? Because we have not configured the other end of the cable, R2. Let us go to R2. On router 2, as we discussed, we are going to configure area 0 and area 200. But before that, I don't have any loopback address with IPv4 address, loopback interface with IPv4 address. So I must give router ID manually. If not, see what happens. I'll go under Ethernet 00 and say IPv6 OSPF 1 area 0. And then see it says I cannot pick up the router ID. So please configure manually. See, so friendly. It is giving you a alert message that router ID you need to configure manually. And let me also go to interface E1 and put the same command area 0. And on interface loopback 0, I'll put this in area 200 as we discussed. But I tell you again, the OSPF process is not started because you don't have a router ID. Show IPv6 OSPF interface brief. Nothing. Because router ID is not configured. Please configure. IPv6 OSPF is not running. OSPF, see how friendly it is. It's clearly telling you where the problem is. So two options you have. Either you go configure an IPv4 address on any interface. Doesn't need to be on loopback interface. You can do it on any interface. Or do this. IPv6 OSPF process ID router OSPF router ID 2.2.2. Now you will see neighbor has come up. Look at the surprise here. Even though it is an IPv6 neighbor, it uses only the router ID. We all know that OSPF uses the router ID both in IPv4 and IPv6. It is the router ID that will be used to identify the neighbor. But the discovery and all, it is not using router ID. I tell you, it is using the link local address. I can prove you that. Show IPv6 OSPF interface Ethernet 00. You can see here a link local address is used to negotiate with a neighbor. I was using this command to show you that. Show IPv6 OSPF interface, blah, blah, blah. Now, router 2 is ready. Let's go configure router 3. Now, configuring IPv6 OSPF on router 3 using interface Ethernet 0/0. Sorry, not loopback. I'm just trying to show you that even if you have an IPv4 address on a physical interface, it can be picked by IPv6 as a route ready. So I'll say 3.3.3.3, 255.255.255.252. Byte mask. Yeah, 3 you should not have. Okay, no, I'll make it as 248. Okay, now why I did this is not for me to ping from anywhere. I just want OSPF, IPv6 OSPF to pick this as a route ready from the physical interface. Interface Ethernet 00, IPv6 OSPF process ID area 0. And you see the neighbor has come up. And then interface loopback 0, IPv6 OSPF process ID area 300. Now if you show IPv6 protocol, you can see that the address from the physical interface is copied as a route ready. Now let's check the routing table. Show IPv6 route. You can see that OIA means other area. OI means what? It is equal to IA. In IPv4, it used to show as IA, inter area. Simply O means local, same area. See, this is same area, no OSPF. These two physical interfaces are same area. Coming from other area, we'll have I. Now I'll be able to ping. Say I'm able to ping. OSPF is over. Any question?